About 1 hour ago, a shadow larger than the North American continent crossed over the Pacific coastline into Oregon in a southeastern direction, heading into the United States. The darkest part of the shadow is racing towards us here now in Casper, Wyoming, as we brace for a spectacular celestial celebration. This is the Great American Eclipse of 2017. My name is Sam Sharkey, and I'm here with the Exploratorium in NASA at Pathways Innovation Center to share the eclipse with you as we experience and explore life in the shadow. In this eclipse, the moon comes directly in between the Earth and the sun, casting a shadow that will go all the way across America from coast to coast. Viewers within this narrow band will be able to see total coverage of the sun by the moon. For most eclipse viewers, this is really a once-in-a-lifetime experience. The last time an eclipse went from coast to coast in the US was in 1918. Here's a photograph from that event, almost 100 years ago. The most recent time a total solar eclipse was visible from the US was in 1979, and here's some footage from that occasion. We're looking for a lot more high-resolution images in this one. We're joined by people all over the world. Witnessing an eclipse is truly a unique and surreal experience. From everywhere, people have swarmed into the path of totality to see it. It's been described as seeing the cosmic eye, or perhaps an X-ray of the sky, or for one viewer, like falling into a trapdoor into a dimly lit, unrecognizable reality. And just like a headline concert or a fireworks show, it's a thrill to experience it with a big group of people. This is my first time in the path of totality, and I am ecstatic about getting a chance to be a part of this, especially knowing that everywhere across the country will experience the same thing. And a big shout out to our home base at Pier 15 in San Francisco at the Exploratorium, where we have a full house watching this broadcast. If you can't join us in the path, you can take us with you on your mobile device. Download our app to watch any of our 5 broadcast streams. In this program, we're going to bring you not one, but 2 totalities. Totality cool, right? We have telescopes and crews in Oregon and Casper, Wyoming here. First, we'll take a look at totality in Madras before the full shadow comes over here to Casper and we send it along its way across the rest of the United States. If you have any questions or want to share how you're celebrating the eclipse, find us at Exploratorium and tag Eclipse 2017. No 2 people experience an eclipse the same way, and we want to hear your story. But don't forget, always view the eclipse safely. Never look at the sun in any form without proper solar protection. You will damage your eyes if not. Sunglasses won't do it. They may even hurt your eyes more. Thankfully, here in Casper, we have telescopes and filters to show us the whole show, and we're joined by NASA scientists Hakeem Olusheyi and Rob Semper from the Exploratorium to tell us what to expect. Where are we at, Hakeem?
Thank you very much, Sam. We're here in Casper, Wyoming. The partial solar eclipse has just begun, and I'm here with my good friend Rob from the Exploratorium, and we're going to take a look at what's happening on the sun.
Let's go. 40 minutes ago, the eclipse started here, and here's a live image from Casper about what's going on. You see that black disk coming over the surface of the sun? That's not something made out of cardboard. That's the moon, the backside of the moon, covering the sun and moving forward. Here's a white light image of what's happening right now here in Casper. 40 minutes from now, it's going to be full-on totality. We can't wait for it to happen. One of the ways we talk about eclipses is talk about contact 1 and contact 2. So Hakeem, what's that all about?
Okay, so when we nerd scientists look at the sun, and during a total solar eclipse, we talk about first contact, second contact, third contact. So imagine that you have these 2 circles. During a total solar eclipse, the moon circle is bigger than the sun circle. And when they just touch, that is what we call first contact, and that is the beginning of the partial phases. Eventually, the moon moves across the sun, and the leading edge of the moon touches the far edge of the sun, and that's what we call second contact, and that's the beginning of totality.
So we're actually seeing some things on the pictures. Just let's talk about the thing you can see really easily, those sunspots.
Yeah, so if you look at the sunspots in white light, you'll see that they're dark on the surface of the sun. And what they are is areas where the magnetic field is so strong that the normal flow of hot material from underneath actually is stopped. Well, it's not stopped completely, but these areas are much cooler, but they're not completely black.
So we've got 2 crews, one here in Casper and one out at Madras. They're 23 minutes ahead. We're going to shoot it over to Ron Hipstrom that's out in our Exploratorium crew out in Madras. Take it on, Ron.
All right.
Oh, Thank you, Rob. We've just been looking at the sun. We're in partial eclipse right now. We're in Madras, Oregon, which is sort of centrally located in the state. We're right outside the Erickson Aircraft Collection, and our sky is a little bit cloudy, but the clouds are very, very thin. We've also had some local fires, wildfires, and that's provided a little bit of haze, but not too much. I think we're pretty good. You can see from our view here that we are actually looking at a really nice eclipse. We have 3 telescopes over here that are watching the eclipse. We have a wide-angle white light telescope that's going to give us a beautiful view of the corona. We have a narrow-angle white light telescope that's going to give us some nice view of sunspots and details on the surface of the sun. And we have a hydrogen alpha telescope way over there, and that's giving us a view of the light of the sun in hydrogen light, which is a light of the sun that comes from the outer atmosphere of the sun. So we're going to be able to see lots of different views. Back to you, Casper.
Thank you very much, Ron. So let's turn to my friend Rob here and tell us what we're seeing differently in Oregon as compared to what we see here in Casper.
Let's put on the image from Oregon first. You can see that in that image, the eclipse is actually much further along. You'll see that the moon is really covering an awful lot of the sun. And if you put on this is the image from Oregon now, not from Casper, Wyoming. You can see how much it's covering. Now let's switch to the image from here in Casper. What you see, it hasn't come nearly as far. That's why the eclipse is going to happen 23 minutes earlier in Oregon than it's going to happen right here. So we can actually talk about this change. It's often talked about the path of totality. This is the path that the shadow takes across the United States. It takes about 1 hour and 30 minutes to go all the way across the United States, from Oregon all the way to South Carolina. And we can see the animation here.
One of the cool things is that if you're on the path of totality, you can actually see the moon shadow racing toward you across the landscape from the west. And once totality is over, you can see it race away in the east. Now, I'm one of the few people on Earth who can actually run at the same speed as the eclipse. But if you can't, just look to the west and look to the east and you'll see how fast it moves.
So let's give you a little primer on the telescopes we've got going here. We've actually got 4 different images coming here from Wyoming. The first one is a white light full disk. That's the surface of the sun, called the photosphere. It's very much white light that's looking kind of whitish here in the sky. We often think of it as yellow. And that's the photosphere. That's the part of the sun that we normally think of and see. We also have a close-up of white light, so we can see those sunspots now that we're just talking about over there at the 9 o'clock image. Now, if we go to the next filter, we actually have a special filter called the hydrogen alpha filter. This is a filter that only picks out a very specific wavelength of red light that shows the hydrogen that's actually in the gas above the surface of the plasma. It's in the chromosphere. And you can actually see much more detail on the sun's surface with this filter. So we have this both in whole disk and also in close-up. So these images we're going to switch around in between. You can see how you can really see those sunspots clearly in the hydrogen alpha. So we got, there's a whole thing about the surface of the sun. It's got all these layers. Talk a little bit about that to us.
Yeah, so what we call the surface of the sun really isn't a surface at all. It's 100 times less dense than the air we're breathing right now. But that's the location where the light is not absorbed when it leaves us. But there's a strange property of the sun, and that is, as you move away from the surface, due to the action of magnetic fields, the atmosphere actually gets hotter. So the H-alpha telescopes shows us material that's about 8,000 degrees. The chromosphere, the red ring around the edge, is about 20,000 degrees, and then the corona is 1,000,000 degrees.
So you're going to see a lot of surface activities from all these surfaces during a solar eclipse, and you're going to see some of it during totality too. That chromosphere will really show up around the edge of the moon's shadow on the sun. But now let's go over to see our telescopes with Bill, our telescope wrangler.
Thanks, Rob. Yes, telescopes are essential to eclipse viewing for our broadcast, and I'm here with telescope technician Bill Dean, who's worked with us over the last 10 years for many of our solar events, including past eclipses. Bill has been working around the clock to get these up. So how's everything looking now, Bill?
Pretty good, Sam.
Pretty good. And what kind of gear are we looking at? Can you tell me about the lenses?
Sure, we have quite a few telescopes here. We have a hydrogen alpha, tight, long focal length for the detail in the chromosphere. We have the wide, white light, which is also detail but in the photosphere. And then we have a shorter focal length, wide H-alpha. Unfortunately, we're having some issues with it, so we may not be able to see that. And a very wide white light. That's a fun one because at totality, we're able to remove the filters, and then we can see the corona.
Beautiful. And walk me through what it takes to set up all this equipment.
Quite a bit. Unfortunately, we have some bad weather, so at night we polar align the mounts. We make the mechanical axes coincident with the Earth's rotation so that the image appears still. And without stars, we have a hard time doing that.
And so you've had sleepovers with these telescopes every night for the past few nights, haven't you?
That's correct.
Well, thank you for all the work that you're doing. And is there anything that might interrupt the image during the broadcast?
If we have clouds go through, certainly. And when we remove the filters, you may see a little bit of shaking at the telescope, but that's only when we're removing and replacing them.
Well, thank you so much, Bill. Now that we know how we're going to be looking at the sun, let's learn a little bit more about the event that's happening. We're going to throw it to Robin Higdon from the Exploratorium along with Leslie Garrison from NASA to give us some Eclipse 101.
Thanks, Sam. I'm Robin, and I'm here with Leslie Garrison, who's a NASA outreach educator. I have to just say, it just got noticeably darker here. The sun's maybe half covered, but all of a sudden the winds come up, the temperature's dropped. It's a noticeable difference.
Absolutely.
So anyway, we just wanted to review some of the eclipse basics for you.
Right. So, Robin, as we at NASA have been crossing the country preparing educators and youth, students, and general public about the eclipse, we have come across some very interesting questions. And so Robin and I have created what we want to call Eclipse 101 to clarify most of your questions.
Yep.
Question number 1, Robin, what is an eclipse?
Of course. So an eclipse is simply when the moon moves between the sun and the earth so that the moon casts a shadow on the earth. That's an eclipse. And you see we have that beautiful animation, but we also have a little more low-tech hands-on demo. We've got the earth here, and using our real sun as the sun, I can cast a shadow on the United States, which is exactly what's happening today. It's really that simple.
Really, and so that's causing what we call a total eclipse. But Robin, there are 2 other types of eclipse that we would like to shed some light on.
Sure. Well, the moon's orbit isn't exactly perfect. It's a little elliptical, it's a little tilted. Right. So sometimes we get different kinds of eclipses. When the moon doesn't completely cover the sun, we call that a partial eclipse. Maybe the moon's a little high or a little low. It's also possible for the moon to be a little bit further away than it is today, in which case the edge of the sun is not covered, and we call that an annular eclipse.
Right, and so you can see the animation. So a total eclipse, a partial eclipse, and an annual eclipse. So today we are standing here in Casper in what we call the path of totality. So Robin, let's explain that also.
Sure, so the path of totality, you've probably heard that a lot, is a place you need to be standing on Earth so that you're perfectly aligned to have the moon completely covering the Earth. Now the shadow that's being thrown on the Earth is actually much bigger than the path of totality. The path is only 70 miles wide, and that's where you need to get into, though, to see totality.
Right, and so we have some really cool footage and some videos there, right?
We do. We have this amazing footage that was taken from a satellite in 2016. There was a total solar eclipse over Micronesia and Indonesia, and you can see in this image that the center of the eclipse is very, very dark. It's called the umbra, and the outer edge is very light. That's called the penumbra.
Right, so that's a partial and a full. So last question, very important question. We repeatedly heard, well, if the moon takes approximately 28 days to orbit the Earth, why is it that we don't have a total eclipse every 28 days, every new moon?
Right, that is a really good question, and it's a little bit complicated. So we asked Exploratorium senior scientist Paul Doherty to explain it, and we have a video of that.
In order to understand the celestial mechanics of total solar eclipses, it really helps to make a 3-dimensional model of the Earth, the Moon, and the Sun. So once a year, the Earth is going to move around this orbit. The yellow string represents the plane of the Earth's orbit around the Sun, the plane of the ecliptic. The hula hoop represents the plane of the Moon's orbit around the Earth. If they were in the same plane, then once a month, the moon would move on the line between the Earth and the Sun, and there would be a total solar eclipse every month. However, the moon's orbit is tilted by 5 degrees, so that as the moon orbits, it can pass way above the plane of the Earth's orbit around the Sun. And that means the shadow of the moon misses the Earth. So most of the time, there is not a total solar eclipse. We've moved around 3 months, a quarter of the way around the Earth's orbit. The moon's orbit is still tilted, but in exactly the same angle as before. The moon's orbit acts like a gyroscope as the Earth moves around the sun. Now, as the moon comes around, it crosses the plane of the Earth's orbit. It gets between the Earth and the sun, and now it can cast a shadow on the Earth and make an eclipse. So at this season of the year, you can have a total solar eclipse. And then again, on the other side of the orbit, 6 months later, you can also have a total solar eclipse.
Hi, so let's take a look at the sun. I'm seeing with my glasses it's well over 50% covered. It looks amazing. I'm sure the telescopes look just as amazing. But we're getting pretty close. I think that umbra, that shadow, is getting awfully close to Oregon. So I thought maybe we'd check in with Ron and see how things are going back there.
Thanks, Robin. We are back in Madras, and the sun is almost completely covered here. I have Kristen Erickson here with me, our NASA-sponsored. This is your first eclipse, isn't it?
It is. I didn't expect this, actually. You know, at NASA Science, we try and reach learners K to gray, but it's gray here now. I think this is a whole new dimension.
Yes, and NASA has a bunch of new observations of the sun, doesn't it?
We do. We have 11 spacecraft, and thanks to our partners across the country with NOAA and the National Park Service, we have 50 high-altitude balloons. We have over 68 citizen science sites called Citizen Kate, of which we have one next door to us. And it's just been a tremendous national effort. It's really just a privilege to be here as part of the NASA family and, of course, the eclipse experts at the Exploratorium.
Well, thank you. We're going to let Kristen go and experience the eclipse with her family. Let's take a look at our eclipse shadow tracker and see where the shadow is. As you can see, it's already entered the coast of Oregon, and it's about to cover over. Jefferson just went into eclipse, and Madras is just a couple of minutes away. I'm going to invite back here Nicole Miner, who is the producer of our whole show here in Madras, and we wanted to get some of her reactions here too. Now, the eclipse tracker that you just saw was just one of many visualizations that the NASA Science Visualization Studio is providing us, and we have to have kudos to Ernie there at the Visualization Studio and all of the other artists who have made all of these visualizations possible. Nicole, you can see the shadow. We're almost in total eclipse now. We have just a little sliver of the sun.
It's incredible, Ron.
Yeah.
You can feel your the arms are getting cool. We've been hot all morning. I've been running around, but right now it's cool. It's also interesting. The crowd was tittering and making a lot of noise, but now it's gone almost very quiet, and it's as if everybody's sort of right on the edge waiting. And it's so exciting, and I can see just the sliver of the sun left there.
Yeah, if you look at our view, we just have just a little tiny sliver left. And so as the moon continues to cover over, we just see that little crescent, and we're approaching totality. It should arrive here in just a minute or so, and we'll begin to actually see the light dim. So far, you haven't been able to watch the light dim because it happens so slowly. But now, actually, I'm beginning to perceive it getting darker as I'm watching.
Yeah.
So we should be able to see on the edge of the sun Bailey's beads pretty soon. I'm going to move up closer to our monitor so I can watch it as the last sliver of the sun disappears. Oops. There we go. We're going to switch to our hydrogen alpha view.
Look at that edge. It's beautiful. And it is getting noticeably darker,
we just removed the filter
folks.
from one of our telescopes, so we're looking there. That's with the filter off. Do not remove your glasses yet. We still can see the bright surface of the sun, so still use your glasses here. Let's go back to the hydrogen alpha view here. And our telescope guys are going to refocus their telescopes to make sure that the white light image is in.
Here it comes, everybody.
It's getting darker. It's
really
getting darker.
dark.
We're very close. Let's see if we can see Bailey's
so
bees now. Let's switch to our white light views.
People are starting to whoop and holler.
It's getting dark
and
visibly
the sky
now.
Is
It's
such
getting
a strange
dark.
color.
It's getting dark, and there we have. Let's magnify that a bit. We have Bailey's beads and the diamond ring effect. We can see the corona right next to the diamond ring.
It's amazing! Oh my gosh! It's amazing!
You can see the crowd
is so
reacting.
beautiful.
The corona has a really stretched out appearance right now. It's stretched out to the east and west.
There's
Probably,
some tall points there.
Yes. It's
incredible.
just amazing. It's dark here. As we look around the horizon is kind of twilight view. And we look up, we can see Venus up in the sky there, quite far from the sun. I can't quite see Mars.
I've got goosebumps, Ron. It's so exciting.
This is really exciting.
Everybody's looking up, and
I think that we're going to actually go quiet here because we want you guys out in internet land to enjoy this and without us talking.
yes,
We might have to
enjoy
comment.
our eclipse.
We have no telescope view here. I'm sorry. We're experiencing a little bit of technical difficulty. We may have one right now. Okay, there's one of our telescopes. Can give you a view now.
We're giving you also a view
Let's
of the
bring
horizon.
up telescope, wide angle. There it is. Okay. Everybody here has grown quiet. I hear the clicking of a lot of cameras.
It's beautiful, everyone.
It's just gorgeous. We have not too long to go here. The corona is just beautiful. It's got a lot of detail in it.
It does, and there's peaks and valleys. It's so beautiful. It's just beautiful, Ron. It's one of, it's so spectacular.
One of nature's most beautiful events. We have that black hole up in the sky surrounded by the pearly corona.
It's just
A
spectacular.
million degrees in temperature.
Those protrusions of the corona are just amazing. People are screaming and shouting. You can see the mountain, Mount Jefferson, behind us now. Oh, I think things are starting to change,
the diamond ring
Ron.
coming out pretty soon. There's the diamond ring
There's the
effect.
diamond ring.
And now we have to put on our glasses again.
Spectacular, spectacular.
Time to put on our glasses. The sun is coming back out.
Should we get back on stage, Ron? And the light is changing so fast again.
It's the light is, it's like someone's turning a dimmer up
yeah,
here.
I feel like we're all of a sudden in the spotlight, Ron. It's very exciting. and it's a spotlight just for us right here, the sun at 10, whatever time it is now.
It is about 10:22
10:22,
now.
okay.
Here. We had our 2 minutes of eclipse, about 2 minutes and 4 seconds.
It was absolutely beautiful.
It's amazing. This was your second eclipse?
This was my second.
Okay, it was my fifth eclipse. So we're really, we're so lucky to be able to see these things.
I know.
The fact that you can actually see these things and travel and go and see them. This is the shortest distance I've ever traveled. I've gone all the way to Africa to see eclipses. And
me too. Last time I was in Western China, but this is right in our backyard. It's so exciting.
And now the light is coming back. As our friend and co-worker Paul Doherty said, once again, we've been saved by the laws of celestial mechanics. Back to you, Sam.
Thank you, Ron. That looks spectacular. I'm so excited to be downstream from that event. Right now, the moon is that classic crescent shape that we often associate with the moon. The sun is that crescent shape. It's getting a little bit darker here now, but that looked incredible. And clearly, the corona was the star of the show there. I love the way it looked. I can't wait to see it in person. And this is possible because in the eclipse, the moon fits just over the disk of the sun, allowing the outer light through. But how is this possible? Here's a small model, not the scale, of the sun and the moon. We know that the moon is 400 times smaller, so how can that be? Well, we shot a video a couple days ago to show an example of how, given a distance, they might look the same size. So you see there the giant sun rolling back, and it's almost the same size as the moon, giving us that corona. And that is the most special part of totality, isn't it? Over the millennia, when people have been observing it, it's been hard to give an objective description of what the corona exactly looks like. We have a slideshow of paintings and illustrations spanning from 1200 all the way to current day of different interpretations people have brought to the corona. I just love the aesthetics that are brought over here, and looking at the way that technology influences what we see it, how our culture influences how we see it. And again, I'm really looking forward to what I'm going to see in the corona today. So let's take a look at where we are in the tracker. We know that it just left Oregon, looking like it's getting closer. And how about we go to one of our telescope views while I find someone to talk to about while we look forward to the eclipse over here. Yeah, you can see how small of a disk it is. Again, the vibe here in Casper is buzzing, lots of crowds. And I found a family who actually works at the Exploratorium that we're going to talk to now to see how they're anticipating this eclipse. Hi, Jessica. How are you feeling?
I'm feeling very excited, and I was just realizing I feel slightly anxious.
Slightly anxious
Like
in
my
a good
heart
way or a
is-
bad way?
Well, in a good way.
Great,
yeah,
great.
Yeah, it's just like seeing the darkness coming on is pretty amazing.
And this is your first eclipse?
No, it's actually my second.
Your second eclipse?
Yeah.
Well, you're still excited. That's great.
Still excited.
And Zoe, I assume this is your first eclipse.
Yeah.
What kind of feelings do you have?
It's really exciting because I've never seen one before. So
Yeah.
Yeah.
It's my first time too. And Eric, you're also a first timer?
It's my first time also. And I think there's a lot of tension around looking the right way at the right. It's such a short moment of totality.
Yeah.
That are we in the right place? There's people up on the hill. Should we be up there? There's a lot. My heart is pounding.
What do you expect to find out or learn after this eclipse? Answer any questions?
Well, one question I've been baffled or I've been wondering about is I've always heard the size of the moon is the same as the size of the sun, but I feel like that can't be true. The moon, relative size, obviously. The moon must be larger.
Well, you'll be able to see it with your own eyes through safety glasses if it looks the same size or not. So let's take a look at this demo table. Have you guys been playing with the pinholes?
Yes.
Yep, indeed.
So we know, if you can get a shot there on the camera, that you can see the crescent shape, whereas before we had the full circle, and we're not going to be looking through these during totality. We'll be able to take off these glasses, but this is a fantastic way to see the eclipse beforehand. So we're going to now send it back to Robin and Hakeem to tell us a little bit more what to expect outside of the corona during this eclipse.
This is going so well. The eclipse is beautiful. The skies are clear. Robin, let's look at our telescopes.
Yeah, let's take another look at them. It's getting so thin. Look at those sunspots. That's incredible detail.
Yeah, and I'll tell you what people might not notice normally is that around the sunspots there are these bright regions that are called plages, and that is the French word for beach.
So it's like a big beach on the sun today?
It's like a big beach on the sun. And you know what? The brightness of the plage is greater than the darkness of the sunspot. So the sun is actually brighter when there are more sunspots than it is when there are fewer sunspots.
That's incredible.
Yeah.
So we're getting very close. It's noticeably darker, as I said before.
And
every
cooler.
few minutes it's getting dark. Yeah, there's a little wind coming up. So let's get people ready for what they're going to see here.
All right. So the sky is already darkening, but once the sun gets covered up to about 97%, that's when the sky really gets dark and the planets emerge.
Yeah, so we have a picture here of what we'll be seeing.
Okay.
And what's weird about it, right, this is not what I'm going to see later on tonight.
No, this sky that we see is the February sky. This is not tonight's night sky. We're going to see the February sky in August.
That's so strange.
Yeah.
So right now, even though it's covered by blue, there's a night sky out there.
That's right.
And then during totality, that blue sky is going to melt away, and we'll see the stars in 6 months.
Yeah, it's like we're in space.
That's amazing.
Yeah, that's
I love
really
that.
cool.
I wish we were in space.
Well, in a way we are.
We could see the shadow of the Earth.
Yeah, we're riding the Earth, our spaceship, through space.
Awesome. Okay, so there's a whole series of events that happens before totality, so let's get into that. What happens first?
All right, so as the moon covers, as the civilian said, the circle of the moon is actually bigger than the circle that is the sun. And the edge of the moon is not smooth. It has mountains, it has valleys, it has craters. And so what happens is that the mountains cover the sun before the valleys do. And ultimately, you get to a point where there's a few valleys where the light is still coming through. And these leave a set of bright points that we call Bailey's beads. And we also see the bright red of the chromosphere.
Right, and so we're seeing an image of this. This is from last year of those little Bailey beads. And what that light is it's light that's sneaking into valleys.
That's right.
Seeing the edge of the moon.
Coming through the valleys.
So cool.
That's right. And
Awesome.
ultimately, only one valley will remain. And it's all about the contrast. And so that valley is going to look really bright in comparison to the rest of the sky. And so, because there's a thin ring of brightness, that one valley looks so bright that it becomes a diamond ring in the sky.
Right, and what we're seeing right now is a prediction of those Bailey's beads. So it was predicting where they were going to be, where we were going to see the bead show up, and then the final amazing diamond ring.
That's right, and that's science. Science is all about prediction. So what are we looking at now, Robin?
That's a diamond ring.
There you go. And you know what? We get 2 diamond rings. We get a diamond ring as the sun is getting covered, and we get a diamond ring as the sun is getting uncovered.
Yep, and one of my favorite things, last year there were a lot of proposals with the diamond ring. Last year in Indonesia, so hopefully that'll happen this year too. So romantic.
Do you have plans for me, Robin?
Well, we'll have to wait for the diamond ring and see.
So once totality begins, things change fast. Because the moon is a bit bigger than the sun, what happens is the edge of the moon touches, and then the other edge has to reach in order for the sun to be revealed again. And so we have 2.5 minutes of coverage. The corona emerges, and what you see with the naked eye is way more fabulous than what you see on a camera.
That's right. So we're getting ready. It's super close.
It's super close.
Yep, and we'll pay close attention to that corona once the moon totally covers the disk of the sun.
That's right. I can't wait. And the sky looks like it's cooperating so far.
Yep.
So, who's next, Robin?
We're off to Sam now.
Back to Sam. Thank you.
Thank you for a lot of information. That's really great to hear for what we're going to expect. I love that coronal prediction. But I'm here with Leslie Garrison again from NASA, who's going to show us some other ways that we can interpret the corona and coronal impression, if you will. Tell us about some of these activities that you have.
Right, so Sam, we selected about 3 or 4 of our activities for educators, rather formal or informal, to actually do with students and with the general public. Our very first one is to predict the corona. So we know that the corona is the outer atmosphere of the sun. So in this activity, we're just asking for volunteers to come up and draw the flares, the plumes, and maybe even the loops that they think they'll see during the eclipse.
So then they can contrast and compare what they've done to what they're going to see.
Absolutely.
And hopefully engage a lot of young scientists.
Simply construction paper and chalk.
Perfect. And over here we have some other volunteers decorating, but I see some other images. And tell me about the NASA quilt project.
Right. So at the 2017 eclipse.nasa.gov, we actually have a contest, and we're asking for the general public to actually do art about what they saw during the eclipse.
Oh, awesome.
Before, after, and we are going to take all of the images that are uploaded on NASA.gov, on the eclipse2017.nasa.gov, on Flickr, Instagram, Facebook, Twitter. Go and please upload your information. And as you can see here, we've already started some art, and we've already started our own quilt. And so please continue to do that if you need more information.
And that'll be put together and be on display for visitors to see after the eclipse.
After the eclipse at the American Geophysical Union meeting in New Orleans, Louisiana, December 2017.
That's where you're from, isn't it?
Yes, it
Excited
is.
to be there. And the final project that NASA offered to educators, I see 3D printouts of the state.
Right, and so this is also a memorabilia. And so in our STEM Innovation Lab at Goddard Space Flight Center, our STEM Innovation Lab team came up with this wonderful project to do with blending NASA technology in with the science and the engineering. So our team and our engineer, Pat Haas, came up with this idea to print the states, 3D printing, that's also a pinhole projector. So you kind of have the state, the path of totality, and a pinhole projector all in one.
Path of totality, all the states. We're in Wyoming here, there in Casper.
Yes.
But we haven't really talked about pinholes yet, but that's really cool. So we have both a circle here in the center and a star where the capital may be. And if I look at the shadow here, I see the star image and I see the circle image. But when we can view the sun, if we pull it slightly out of focus, we're seeing crescents in both. And that is mirroring the image that the sun is projecting right now. If you look up with your glasses, it's going to be kind of that shape. It's beautiful. Oh yeah, you got to get kind of far away like that.
That's beautiful. And you can also download these pieces at eclipse2017.nasa.gov.
Thank you, Leslie.
Right.
So I want to take another look at a different sort of pinhole. Yesterday, we shot what the sun looks like through this pegboard here against a white wall. So if we have that image up, you can see that you do see full circles, circular images of the sun. Now cutting back, same pegboard, same surface, but you see the crescent. Again, watching this change over time is really fantastic because I want to think that it's just the circles, but really it's the light being sent just through this small hole so we can see the image of the sun. Really a great, safe way to look at it. Let's send it back to Ron in Oregon to see how they're doing after that, their impressive totality.
Thank you. We're back here. I'm back with Kristen. Tell me about your first experience.
Oh my goodness, you know, Robin warned me that this was going to be indescribable, and you guys were right. And Hakeem, I mean, you know, I know that you've seen one or two, but this is nothing like the very first time. My goodness, it was really incredible.
It's an amazing experience. We're now out of the shadow. We can actually go back to the shadow tracker again and check where we are. Let's see that shadow tracker. And we don't, almost there. There we are. We can see that the shadow tracker, I have to look closer at the monitor here, is just out of Idaho, and it's entering Wyoming right now. That shadow is coming at, we're sending that shadow to you at about 1,500 miles an hour. We're sending it express, and we're going to, hopefully you'll take delivery of that shadow in about 20 minutes.
You know, Ron, the thing that's so amazing, it's kind of nature's reality show in this, whole experience. I mean, some of the places around the country aren't as fortunate as us.
I know.
You know, there's cloud cover, there's storms, and we have just been so lucky here at Madras.
We have. And Nicole Miner has some of our younger observers, and let's get some reaction from them.
Thanks, Ron. Okay, well, I'm here with a bunch of people at the Madras location at the airport, and I have some kids with me. Melina, what'd you think of the eclipse?
I thought it was really cool, and I thought that, well...
Do you like it?
Yes.
Good. Oh, good. Okay, how about you, Jack?
Just watching the time tick by and just waiting for the eclipse to happen. And as it got darker and colder, it just got more exciting after the minute one.
Cool. What did you think, Gina?
It was just a very thrilling and marveling experience, and I'm really proud that I got to be a part of it, and proud to those who helped assemble it.
Excellent. What about you, Mary Claire?
Well, it was even more beautiful than I expected it to be, and I'm so grateful that I got to be with the people here from the Exploratorium working on it. It made me so happy.
Okay, we're ready to go back to Casper, and we're all very excited here. Good luck, Casper, with your totality. Bye from Madras.
All right, I'm here with my fellow NASA astrophysicists, so we're about to seriously geek out. A lot of the activity that we see on the sun, like the sunspots, they're due to magnetic fields on the surface of the sun, and those magnetic fields are not always the same. So Eric, tell us about that.
So it's really kind of funny. The sun is a variable star. It goes through an 11-year cycle where it gets more active. There are more sunspots, more solar flares, more coronal mass ejections that you can see on the left here, to less active where there are hardly any sunspots, hardly any solar flares. We're actually really lucky because we're in what's called solar minimum. It is the time when the sun's supposed to be quiet. But there happens to be two really nice sunspot groups on the sun, because that's the solar minimum is just the average. And so we're really lucky that right now we've got good solar activity. Actually, in the X-rays, the sun's been more active than I've seen it in many months.
Yeah, I know. It's really crazy. And, it's really interesting because just like the Earth's magnetic field protects us from cosmic rays, so does the sun's. So when the sun is more active, we have more protection from galactic cosmic rays.
Yeah, so it's actually, if you want to send a manned mission to Mars, you want to send it when the sun's active, because the galactic cosmic rays that are coming from the distant parts of the galaxy are a lot harder to protect against. Here you can see the sun in its really active phase. There are lots of active regions, sunspots, and the magnetic field's just popping, constantly changing. This is a really neat, and this is in high energy, so this is X-rays.
Wonderful. And where you see bright stuff in X-rays is where you see darkness in the visible light. It's where those sunspots are. And those sunspots are due to solar activity. And when I say solar activity, I mean magnetic fields. And what's happening there is the magnetic fields are so strong, they disrupt the normal boiling of material, hot material from the interior of the sun to the surface.
In this image here, you can see that these sunspots are bigger than the Earth.
That's right.
Really amazing. These are storms on the surface of the sun that are larger than the Earth.
That's right. And we're going to see some really cool activity around the edge of the sun because we've already seen what happened in Oregon.
Yeah, so, I mean, the sunspots, there's a couple prominences that I hope to be able to see. It's really amazing. So here's a picture of a prominence. This is a loop of hot gas coming off the surface of the sun that's like a fluorescent light. It's glowing gas trapped in a magnetic loop, and you can see those during a total solar eclipse off the edge of the sun.
That's right. That image looks like one in the emission of helium, and so that material is about 20,000 degrees. And we call that either the top of the chromosphere or the bottom of the transition region. And it's really interesting how we have a almost 6,000 degree photosphere. Above that, a chromosphere from 8,000 to 20,000 degrees. And above that, a corona that's millions of degrees. And all of that is due to magnetic fields.
Yes, so the magnetic fields then spread out through the entire solar system and actually blows a bubble in interstellar space.
And can affect us here at Earth,
and
right?
can affect us here at Earth. Those magnetic fields can hit the magnetic field of the Earth and cause the magnetic field of the Earth to move. That's what we call geomagnetic storms, space weather. And that can not only affect our satellites and astronauts in orbit, but it can actually affect communications for airplanes and can affect our power grid. There have been solar storms that have caused blackouts here on the planet.
That's right.
For moving the magnetic
89.
field. Yep.
Yeah.
So it's really, that's one of the reasons why we study the sun, is because it's not only important for life here on Earth, but how it changes can affect us right here on the ground. That's why NASA studies it.
All right.
Okay. So maybe we've got the telescopes now, and here you can see live that we're at a little crescent. The light has changed. It's really starting to get spooky.
It's spooky, it's cold,
Yep.
and I'm telling you, we've been here a few days, and normally it's really hot at this time.
Right. So we're going to head back over to Sam.
Thank you.
Thank you, and you are right about it being spooky. We're just 2 minutes away from totality. I can't believe how small the sun is now. It really just looks like a clipped fingernail, just a real sliver, and I can't believe that soon it's all going to be gone. Looking around me, we're in some foothills. You can see the valley behind me. It's changed to a pinkish color almost. Definitely a lot more sharper shadows, and people look like they're in like vivid, high frame rate movie or something. But I'm here with Mario because he's an educator from the Exploratorium. This is also his first experience in totality. So how are you feeling?
Oh my God, I am so excited to be here. It's amazing.
And what did you do to prepare for this trip or for the eclipse?
I was trying to figure out as little as possible. I know that the moon blocks out the sun, but Isabel Hawkins, who's an astronomer in the Exploratorium, she gave me the rundown on the airplane, and it's been so amazing.
And so are you going to be taking any notes or making any observations, or are you just going to try to experience it?
I'm going to lay on the grass and look up into the sky.
Perfect. So, well, if you didn't know any of this information, didn't know it was the moon blocking the sun, it's getting very spooky right now. What do you think it would be happening, or how would you describe it?
Oh my God, I think it'd be the end of days, or maybe revert back to my animal instincts and just go to sleep.
That is probably a safe thing to do. And is there a special occasion that you're here for, or you have some history with eclipses, yes?
Yes, I do. My grandmother saw the 91 eclipse that went through El Salvador, so I'm the third generation to see an eclipse.
Third generation seeing an eclipse. Hopefully it's not much more. We are getting so close. I don't know how close, but it is getting dark. It's a pink light. I'm thrilled. The crowd is buzzing. Let's send it back to the professionals who know how to talk us through this. Robin and Hakeem, take us through totality. I cannot wait.
Robin, this is amazing.
Yes, it's getting so exciting.
Yes, it's getting so exciting.
We're very close to totality here. It's very thin. I've never seen it so dark.
Yes, I've never seen it get dark for so long prior to the end of totality.
And I think we're starting to see a little bit of the corona.
Oh my goodness.
Are we getting any Bailey's beads? I'm not seeing them yet.
Here it comes.
Oh, we're close.
Oh my goodness, we have a diamond ring.
Oh
my God.
We're actually getting a diamond ring.
Oh wow.
It is beautiful.
It is beautiful.
My goodness.
I see the planets.
Yep, the corona is so bright.
Oh my God.
I see streamers stretching out at about 2 o'clock and 7 o'clock.
We have a few wispy clouds up in the sky, but they're not really blocking anything.
The temperature, it's dropped, I'm going to guess at least 8 or 10 degrees.
Oh, yeah.
If you look around, we're getting an orange glow on the horizon.
Wow.
It's sort of a strange sunset behind us.
It's a 360-degree sunset happening right now.
Right, but the detail of the coronal streamers.
Goodness. That is so beautiful.
It is.
Yeah, I see 3 areas of streamers. I can't really see in chromosphere. My eyes aren't good enough.
Yeah, mine either. In fact, it's interesting. I usually see a little bit of pink and those prominences looking pink from the chromosphere, but this time it's all white. We've got an all-white eclipse here. It's gorgeous.
This is so beautiful. Wow, this is I see the pink prominences sticking out on our image from our telescopes right now.
There we go.
It's
wow.
a nice U-shaped prominence.
It's incredible. Beautiful.
Shaped by the Earth's magnetic field.
That's right.
Wow.
but it looks very big in the sky.
Yes.
There's wispy clouds around it. I'm not sure if our telescopes are picking it up, but it's not obscuring too much of our view.
Yeah, if you have a camera, if you have a telescope, typically they can see right through the clouds. And so we're seeing some very beautiful chromosphere on our images. We're seeing the U shape that the magnetic fields is as they're shaping the plasma. This is so amazing. This is so surreal.
It just feels so incredible. I can't believe that it's before noon in the morning and it's this dark.
That's right, that's right. And the eclipse path of totality is only about 70 miles wide, which is pretty much the size of my bicep at full flex. But it's moving really fast. So it goes by us quick.
That bicep, huh? Again, the full disc is looking amazing. That black in the middle, the contrast between the corona and the moon is so intense that it looks like a big black hole in the sky.
It really does. It's surreal. We've seen it in the movies. We've seen it on television programs. But to see it in real life is really amazing.
That coronal streamer at about 7 o'clock is really reaching out far.
That's right.
A very, very long one.
That's right. And also the one at 2 o'clock is reaching out there. You can really see the helmet shape, as we call it.
Yep.
Yeah, and look at the material suspended above the surface of the sun in our telescopic view here.
Right.
And there's a diamond ring. Oh my God.
The sun is coming back. We're getting a diamond ring. Beautiful.
That was so beautiful. Oh my goodness.
Round-shaped diamond ring coming out.
Wow.
Absolutely gorgeous.
Yeah. The diamond ring is the sign that it's time to put the eclipse glasses back on.
That's right.
At the end of totality.
The sun is coming back. It's gotten lighter significantly already.
That was amazing, Robin.
That is absolutely incredible. It's hard to remember to not look.
That's right. That's right.
Without my naked eye now, but we've all got to have our glasses back on.
That's right.
Absolutely beautiful.
The shadow
light is returning.
Is now headed to parts east.
That's right. It's zooming off to our friends in Carbondale, Illinois.
That's right. An hour and a half is the time it takes to cover the entire country. So we had our moment. After this, I'm going to run up and catch it.
Yeah, I can hear you can run about, what, 1,500 miles an hour?
I can run up to 3,000 miles per hour, but, you know, I typically hold back so I don't mess up my shoes.
That's right. Good idea.
Yeah.
What a beautiful eclipse.
Wow.
Again.
The sky is brightening again.
The sky's gotten so much brighter. I'm not feeling warm yet, but I'm sure it'll warm up soon.
That's right. The sky does weird things during an eclipse. So we've had clear skies here, but now the clouds have come in.
It is. I think the change in the temperature sometimes causes clouds to form or to dissipate. It seemed like they were forming this time.
Yeah, it seemed like they formed this time. But they didn't. They weren't too thick, so we got to see it all.
It's true, and the crowd went wild here. We have a nice crowd here, a mix of people from around the world and local folks from Casper. So with that, I think we're going to wind it down and get some. Sam's going to talk to some people about how they felt about the eclipse.
Thank you, Robin. I'm smiling here. You can tell it felt like I just came out of a tunnel, maybe one of those rides that I was on with all my friends, and this emergence was spectacular. I have some tears in my eyes. I don't know if it's the sunscreen or the sunblock, but I'm here to take some reactions with Michelle, who is with Citizen Kate for this project. And remind me of your last name again?
Wistison.
Michelle Wistison. So you just witnessed the eclipse. How was that experience for you?
I have to tell you, it was a big relief because I have this project here that we wanted to capture the data for NASA. So we got to see it. I'm so relieved, yes.
And how did it compare? Have you seen one eclipse before?
I have seen one before. The corona looked very different from the last one I saw. And this had a little bit of high cirrus cloud, so I didn't get to see as much of the stars, but it was still great. Just fantastic.
We're working with high school students here.
High school and college.
Your high school, your first eclipse experience.
Yeah.
Do you have some words to put to this?
Yeah, I've looked at so many pictures in preparation for this, like to study what it's going to be like when it actually happens, but none of that could have prepared me for actually seeing it in real life.
Awesome. We're glad that you're here. And any reactions from this side?
I think I'm actually crying, so it was the best thing I've ever seen, by far.
Take a moment and collect yourself. Any other words you guys want to share?
I mean, I wasn't ready for how long it was going to be. I thought that, I had to pull the lens cap off and make sure that we got our data, and I was like, well, that's time, and then I was like, oh, we've got a whole nother minute and 20 seconds to go, and I mean, just being able to be like, oh, we have time to watch this and just enjoy it, and man, it was amazing.
Well, speaking of data, this is about a science project. Can you tell me quickly about what Citizen Kate's all about?
Citizen Kate is Continental America Telescopic Eclipse experiment, and so it's college students, high school students that are collecting data for NASA, and then they'll send it to NASA, stitch it together so NASA will have 90 minutes of the corona to look at.
And there's citizen scientists all the way across the country gathering this data, and we're going to see a mega movie, not the mega movie, 90 minutes later.
Yes.
Thanks for your help there, and thanks for your reaction, guys.
You're welcome. Thank you.
We're still in a tizzy over here. We're going to send it back to the experts who have seen some. Rob, Hakeem, and Leslie, let us know how you felt.
Wow, Leslie, that was your first eclipse.
That was my first. I will never forget that. That was absolutely breathtaking.
What did you see? What happened that you didn't expect?
Oh my gosh, I don't know. I don't know what I thought to expect other than everybody kept saying an eclipse, but now I actually have something to totally reference when I'm doing my teacher professional development and talking to outreach. That was beautiful.
That was.
Absolutely.
Hakeem, you've seen a few of them.
Yeah, this was my 4th total solar eclipse, and I tell you, it really was one of the best. The time period that the sky darkened was much longer than I ever experienced before. In past eclipses, it was much more of a sudden onset of darkness.
Right.
Yeah.
Yeah, for me, I've seen 6 eclipses. This was one of the most spectacular ones I've seen. 2 things I noticed. One is around the horizon, we had this amazing sunset. So while you're looking up, you also have to look around. 360-degree sunset. We had a great view here in our location. We could see so far into the past. Also, the darkness was much darker than the last one I was at in Micronesia.
Yeah.
We had clouds that were actually scattering the light into our sight, so it was much lighter. This was really pretty dark.
Yeah, and I tell you what was really cool about this one. This was the first time I wasn't taking scientific observations, so it's a much more chill experience to watch it, because we talk a lot about the science, but ultimately it's just a really awesome, cool thing to observe, right?
And speaking of chill, did you notice the temperature change?
Oh, did I ever?
Yeah.
Yeah. We've been out here for 3 days.
For 3 days.
And we've been sweltering hot at this time of day.
Right.
But today, I'm still chilly.
A little chilly, yes.
Just the way the environment changes. The crowd went wild, as you heard. They were just so excited and applause. It just is a visceral experience.
That's right.
It's a spiritual experience as much as a science experience.
That's right. And if you are not on the path of totality, I have a single word for you. YOLO. You only live once. You gotta travel to one of these and see it, because what you see on camera does not capture the experience in real life.
Right.
So this is going across the country. More of you are going to get to see this as it happens, as with this thing zooms across the U.S. We're really excited to bring this program to you. Maybe we should get a picture of what's happening in the sky, because you know the moon is still moving. It didn't stop.
Wow.
Look at that amazing prominence there on the edge.
That is really cool.
That's really cool, and it's going to slowly drift away.
Yeah.
And what always amazes me about this, in some sense, is the alignment actually works. You can predict this.
That's right.
And it happens. And when I see it happening, I'm so amazed that the calculations worked. You know.
That's right. And that's what science is. Science is prediction. Leslie?
We got a great prediction. I can't wait to call my dad in Louisiana and tell him what I saw.
That's right.
Okay, so we're going to go out to audiences now and send some more. And the time machine will roll, and we'll get some audiences out here reactions. So off to Sam.
Bye.
Thanks, Rob. You're right. The crowd here was going wild. I was among them, and I'm here with some folks here who had some big reactions as well. We have a young woman named Madeline. This was your first eclipse, I assume, yes?
Yeah.
And how were you feeling right before the sun got dark?
I was excited because I knew it was going to be dark even though it wasn't night.
And then when it did get dark, was it what you expected?
Well, it was dark, but it wasn't as dark. I thought it was going to be like midnight, but it was sort of sunset.
And would you recommend it to your friends to see a total solar eclipse? Well, we maybe not see you at the next one. Let's check in with Dad over here. Yep. And so, have you seen a total solar eclipse before?
Never in my life, no.
And what brought you here? How far did you travel?
I came all the way from Italy to experience this eclipse. This was my first one. So I'm an actual astronomer. So I knew all there is to know about solar eclipse, but experience it firsthand, that was like the greatest moment of ever.
Yeah, and so do you think you captured the data you wanted, or the observations?
Say again, sorry?
The observations you were looking for?
Yeah,
were they successful?
Absolutely. So everything, like not just the eclipse itself, but it's getting darker, it's getting chillier. Everyone is exciting. It's this one moment in time. Everyone is looking forward to it, and the crowd that cheering up when the sun disappeared. It was so awesome, so great, and I love to see the next one. When is the next one?
Next one is, we'll tell you later, 2019.
Okay,
Thank you. I want to go over here. Eric, is the moon the same size as the sun from where we're sitting?
It was, yes, it was the same. I mean, but the corona was amazing. And
how would you describe it? What color?
White. I mean, blue? Okay.
Yeah.
White, blue, we don't know. I want to go to one more person who experienced her first total solar eclipse. What's your name?
Marty Salady.
Marty, and how old are
No,
you?
you can't have my phone number. I don't give it out to just anybody.
But I'm interested.
But maybe some of, well, maybe. Okay.
Well, I think under the diamond ring, it's appropriate time to get closer to people.
Okay.
How was this experience for you?
Wonderful. It truly was. Well worth the price we paid coming in.
Perfect. Thank you so much.
You bet.
And we are going to send it back to Hakeem and Eric because the total solar eclipse is not the only thing going on with the sun these days. Hakeem and Eric are going to tell us about an exciting new project.
Thanks, Sam. He just can't resist the ladies and the lawn chairs, I tell you. I'm here with my friend Eric, and we're both solar physicists. I started off my graduate school sending up rockets in order to take observations of the sun, and one of my heroes was Eugene Parker. And now he's going to tell us about the Parker probe.
So next year, NASA is launching the Parker Solar Probe that is going to get closer to the sun than any other mission we've ever flown. It's going to get actually within 4 million miles of the surface of the sun. The Earth is 93 million miles away, and so we're 25 times closer. This is amazing. We've got an enormous heat shield in the front. I like to joke that my instrument hides in the shadows.
Wonderful.
And we're going to study the sun like we've never been before because we're going to be where the action is.
That's right. Now, a lot of the spacecraft, we're seeing that, one of the things I know about doing research in space is you don't want to have too many moving parts. And I see the antennas are popping out, the solar panels are popping out, and the heat shield is a key element. So it's already out at launch. Is that the case?
Correct, yeah. So it's in its right position. The antennas have to pop out because they have to get further from the spacecraft than you can keep in the fairing.
That's right.
And the solar rays actually move in and out as we get closer and farther away from the sun.
Now, one thing about doing space research, when you want to go to the outer solar system, you'll typically take a swing around a few planets to get a gravitational assist to get your speed up. But the solar probe, the Parker probe, is going to do something different, right?
Right. So actually, the first time we go in, although we'll get closer than any other spacecraft have been within a couple months after launch, we don't get the real closest 4 million miles until 6 years later. And we do that by swinging by Venus and losing energy so we can fall into the sun, closer and closer to the sun. It's a really neat instrument.
Yeah, and if you don't lose that energy, you might literally fall into the sun. Right?
No, you have to lose more to fall into the sun.
Oh, that's right. I see. That's right. The faster you go, the bigger your orbit.
Yep.
Exactly. So tell me about your instrument on the solar probe. What are you going to be measuring?
So my instrument measures the highest energy particles, what are called solar energetic particles.
SEPs.
SEPs.
That's right.
They are moving at nearly the speed of light, and they're the ones that are dangerous for astronauts and for spacecraft. But understanding how they're accelerated, this is the first time we're going to go there to the action.
And those SEPs are primarily protons. Is that the case?
So it's like the rest of the universe. It's 90% protons, 9% helium, 1% all the heavier elements.
That's right.
Everything up to iron and even heavier.
That's right. And when you think about the sun, you don't typically think of iron. You think of hydrogen and helium. But when you look at those coronal images, not during a total solar eclipse, but the ones we get from space, a lot of that is due to the emission of iron ions, which is pretty incredible.
Yeah, it's a small part of the sun, but it's bright enough that we can see it.
That's right. Yeah. Because those are big atoms, that means they're very likely to get hit. Those electrons move into higher energy levels, and then when they drop down, they emit the light that we then observe with our telescopes.
What's nice is that those heavy atoms give off very precise wavelengths of light, and when you look at the sun in that wavelength, you know exactly what the temperature of the gas that you're looking at is.
Exactly. Now we're looking at another image from our telescopes here in Casper, and we see that prominence is still visible, even though the bright image of the sun is there.
Yeah, so that's a hot loop of gas, as I said before, controlled by the magnetic field of the sun, and that's a beautiful prominence.
Yeah, I tell you, I'm so happy that I chose astrophysics as my career to spend my life. I used to grow up in the countryside building little things and fixing things, and that's the exact same thing you do, right?
Yep. They pay me to have fun. I love working for NASA.
Yeah.
But now we're going to turn it back to Sam to close out the show.
Thank you, Eric, and what a show it's been, especially here in Casper, Wyoming. Eclipses are sudden and predictable. We've been planning for months and months and even years for this event, and it just went by so quickly. So much to see in such a short amount of time. So if you miss this or you're not in the path of totality this time, your next opportunity is going to be July 2nd, 2019. That total solar eclipse is going to go through Argentina and Chile. If you can't travel that far, the next eclipse in the U.S. will be on April of 2024. You can see that map right there. And we know that we can predict eclipses because we're familiar with some celestial mechanics. Just like the rising sun or the phases of the moon, there are some things that we can count on. Let's take a look at a map of the eclipses for this first quarter of this century. You can see they're all over the place and they look kind of random, but in prediction, you look for patterns. So we'll go to the next slide and you can see that these two eclipses follow a somewhat similar path. Just like the next slide, somewhat similar path. These are of the same family because all the cosmic alignment is very, very close, and so you get a similar eclipse. And that's how we begin to make the predictions. If you look at this path here in 2017, this is a part of a larger family. This part of the Saros cycle was in 1999. It's going to happen again in 2035 and beyond. Over the course of about 700 years, actually. And that's what this animation is showing you, that beautiful wave structure of the eclipse, a path of totality going across the Earth. And that's how we know when eclipses are going to happen in a shorthand. Of course, for more information, visit exploratorium.edu for lots of videos and lots of educational resources. Total solar eclipses as we know them will not be around forever. In about 400 million years, the moon's going to move far enough away from the sun that we don't see a total eclipse anymore and won't be able to see the corona. We'll have too much light to see, so we're glad that we're able to experience them now. And again, we're sending the shadow along to the rest of America. We're so happy everyone's going to get to experience it. And we want to thank NASA for supporting this broadcast, as well as additional support from the Gordon and Betty Moore Foundation, and a big thanks to the Trona County School District for hosting us here at this site. And of course, none of this would be possible without the dedication and expertise of our crews here in Wyoming and Oregon and back home at Pier 15. And so eclipses, they're predictable, but they're sudden. And so it's felt with the news of the passing of our teacher, friend, mentor, and colleague, Paul Doherty. Paul has been a part of the eclipse broadcast since 1999 with the Exploratorium, and this one has been no exception. Paul, we love you. And it's with your exuberant curiosity that we're going to continue to enjoy this eclipse, as should the rest of you. Thanks so much for joining us, and enjoy the shadow.